So hey there, welcome back to another video of Monotech YouTube channel. And this video I'll be talking about are transformers, a deep learning method. A transformer in machine learning is a deep learning method model that uses the mechanisms of attention, differentially weighing the significance of each part of the input sequence of data. Transformers in machine learning are composed of multiple self-attention layers. They are primarily used in the AI subfields of natural language processing, NLP, and computer vision. CV transformers in machine learning hold strong promises toward a generic learning method that can be applied to various data modalities, including the recent breakthroughs in computer vision, achieving state of the art standard accuracy with the better parameter efficiency. Vision transformer and image classification. Image classification is a fundamental task in computer vision that involves assigning a label to an image based on its content. Over the years, deep convolutional neural network CNNs like YOLO V7 have been the state of the art method for image classification. However, recent advancements in transformer architecture, which was originally introduced by natural language processing and has shown great promise in achieving competitive results in image classification task. So, however, recent advancements in transformer architecture, which was originally introduced for natural language processing (NLP), have shown great promise in achieving competitive results in image classification tasks. So, an example in Cross VIT, which is vision transformer in image recognition, a cross-attention vision transformer for image classification. Computer vision research indicates that when pre-trained with a sufficient amount of data, VIT models are at least as robust as ResNet models. Other papers showed that vision transformer models have great potential for privacy preserving image classification and outperform state of the art methods in terms of robustness against attacks and classification accuracy. Difference between CNN and VIT. So VIT versus CNN vision transfer. VIT achieves remarkable results compared to convolutional neural network CNN while obtaining substantially fewer computational resources for pre-training in comparison to convolutional neural network. CNN vision transformer VIT show a generally weaker inductive bias resulting in increased reliance on model regularization of or data augmentation Ogreg when training on smaller datasets. The VIT is a visual model based on the architecture of a transformer originally designed for test back based tasks. The VIT model represents an input image as a series of image patches, like the series of word embeddings used when using transformers to text, and directly predicts class labels for the image. VIT exhibits an extraordinary performance when trained on enough data, breaking the performance of a similar state of the art CNN with 4x fewer computational resources. These transformers have high success rates when it comes to NLP models and are now also applied to images for image recognition tasks. CNN uses pixel arrays, whereas VIT splits the input images into visual tokens. The visual transformer divides an image into fixed size patches, correctly embeds each of them, and includes positional embedding as an input to the transformer encoder. Moreover, VIT models outperform CNNs by almost four times when it comes to computational efficiency and accuracy. The self-attention layer in VIT makes it possible to embed information globally across the overall image. The model also learns from training data to encode the relative location of the time image patches to reconstruct the structure of the image. The transformer encoder includes the following multi-head self-attention layer (MSP). This layer concatenates all of the attention outputs linearly to the right dimensions. The many attention heads help train local and global dependencies in an image. Multi-layer perceptrons (MLP) layer. This layer contains a two-layer with Gaussian error linear unit GELU layer norm LN. This is added prior to each block as it does not include any new dependencies between the training images. This thereby helps improve the training time and overall performance. Moreover, residual connections are connected after each block as they allow the components to flow through the network directly without passing through nonlinear activations. In the case of image classification, the MLP layer implements the classification head. It does with one layer at the pre-training time and a single linear layer for fine-tuning. What is self-attention of a vision transformer? The self-attention mechanism is component of the transformer architecture, which we'll cover in the next video. So that was all for this one. Thank you for watching.